Hi everyone. In this lecture, we will discuss the definition of propositional logic. In propositional logic, we study these concepts. So we already know what is a proposition, what is the definition of propositional variable, and what is the definition of all the logical connectives that we study, like negation, conjunction, disjunction, implication by implication, exclusive or NAND or. So these connectives, okay, propositional variable, proposition, all these definitions we know. But what is the definition of propositional logic? In some interview, if they ask you what define propositional logic, then what answer will you give? Okay, because you know the definition of proposition, you know the definition of propositional variable, so you know the definition of all the concepts that we study inside propositional logic. Okay, but you don't know the definition of propositional logic. This is what we want to discuss in this lecture. Okay, so before we see the definition of propositional logic, let us quickly go through all the definitions of all these concepts. Okay, so let's quickly see what is the definition of a proposition. Proposition, another name is statement. So you can call it proposition or you can call it statement. What is this? Proposition is basically a sentence which is either true or false. This is the very simple definition. Okay, and more formal definition if you want, then proposition, or you can say statement, that is nothing but a sentence that declares a fact that is either true or false but not both. Okay, so what is a proposition? Proposition is a sentence that is a declarative sentence which declares a fact, and that is either true or false. It cannot be both. So if it is true, then it is not false, or I can say if it is not true, then it is false. If it is not false, then it is true. So this is the definition of proposition. This is a sentence which is true or false. For example, you can notice 1 plus 2 equal to 4. This is a declarative sentence because it declares the fact that 1 plus 2 that is equal to 4. So this is a proposition because this is a declarative sentence which declares the fact. And this declares a false fact. So I can say that this is a proposition. Yes, this is a proposition, but the truth value is false. So this is a false proposition, I can say, or I can say this is a proposition whose truth value is false. Similarly, this is also, I can say that this is also proposition. It declares a fact that 2 multiplied by 3 is equal to 6. So this declares a true fact. So the truth value is true. So you can notice, remember, proposition is either true or false. So if you have any proposition, then that is either true or false. So proposition is either true or it is false. So if it is not true, then it is false. If it is not false, then it is true. So not true means false, not false means true. This is the definition of proposition. For example, these are also proposition. Grass is green. This is a declarative sentence. It declares the fact that grass is green. So this is also a proposition. Similarly, this is also a proposition. 2 is an odd number and 3 is an even number. This is also a proposition. You can notice grass is green. This is a proposition. This is a true proposition. So I can say the truth value is true. And 2 is odd prime and 3 is even number. This is a false proposition. This is also a proposition, but this is a false proposition. 1 plus 2 equal to 3 or 2 plus 2 equal to 5. This is also a proposition. This is a true proposition. This is a proposition whose truth value is true. Similarly, this is a proposition whose truth value is true. Similarly, this is a proposition whose truth value is false. So this is called truth value. This is called truth value. So similarly, this is a proposition and whose truth value is true. So these are the propositions, and these so the proposition truth value can be either true or it can be false. Now, what is not a proposition? So for example, grass, this is not a proposition because this is not a declarative sentence. Okay, we are just saying grass. So this does not declare any fact. Similarly, hello, this does not declare any fact. This is just a I can say this is just I can say greeting. Okay, so this is just an imperative sentence, or I can say this is a greeting word. So this is also not a proposition. 1 plus 2, this is not a proposition because it does not declare any fact. Okay, similarly, is grass green? This is a question. This is not a proposition. So these are not propositions. Okay. Now, the next concept we need to study is what is atomic proposition, what is compound proposition, and this is important concept. So, and many students, they have misconception in this concept, so I just want to make it clear. So what is this atomic proposition and what is this compound proposition? Let's take this example. These three propositions you, okay, consider. So all these are propositions. You can notice all of them are propositions. So we have total three propositions we have. Now you can notice, now just notice this proposition, this proposition you notice. In this proposition you can see that this part is also a proposition. So I can say this part is also a proposition, this part is also a proposition. So I can say, if you focus on this whole proposition, okay, this whole proposition, if you focus, then in this whole proposition you have two parts which are proposition. This part is also proposition, this part is also proposition. Okay, but notice this proposition. So in this proposition there is no part which is a proposition. So I can say that this cannot be broken. Basically there is no part which is a proposition. Okay, similarly in this proposition, this is also proposition, but there is no part which is proposition. Okay, so see the difference between these three propositions. So you can notice, in this proposition there is no part which is proposition. Okay, but in this proposition, okay, you can notice this part is a proposition, this part is a proposition. So that's the definition of atomic and compound proposition. These are called atomic propositions. Because why they are called atomic propositions? Because no part of them is a proposition, and this is called compound proposition. Why this is called compound proposition? Because it has part which is proposition. So this whole box, this whole statement is a compound proposition. Why? Because you have part in this complete statement, this part is a proposition, this part is a proposition. So that's the reason this is called compound proposition. Okay, so atomic proposition is a proposition which cannot be broken, or I can say atomic proposition is a proposition in which no part is a proposition, or I can say that atomic proposition is a proposition whose truth value does not depend on anyone else. But you can notice the truth value of this statement: grass is green and snow is white. So the truth value of this statement, the truth value of this statement will depend on the truth value of this statement, also on the truth value of this statement. So I can say atomic proposition is a proposition whose truth value does not depend on anyone else. The truth value of this statement does not depend on anyone else. The truth value of this statement does not depend on anyone else. But the truth value of this statement, it will depend on the truth value of this and the truth value of this. Okay. So that's the reason this is the definition of atomic proposition. What is an atomic proposition? This is a proposition in which no part is a proposition. So this is the very important point. So atomic proposition means no part is a proposition, or I can say that atomic proposition is a proposition whose truth value, whether it is true or whether it is false, that does not depend on anyone else. That does not depend on truth value of any other proposition. Okay. Similarly, I can say that atomic proposition, basically, that is by itself true or false. Okay, so atomic proposition is either true or it is false, but the truth value does not depend on anyone else. Okay, so this is the idea. So this statement, you notice, this statement is either true or false, but the truth value will not depend on any other proposition. Similarly, this is either true or this is false, but the truth value will not depend on anyone else. Okay, but you notice this proposition is true or false, but the truth value will depend on the truth value of this part and the truth value of this part. Okay, so this is the definition of atomic proposition. Atomic proposition is a proposition in which no part is a proposition. So atomic proposition is by itself either true or false, because it does not depend on any other proposition. Okay, so this is the idea. Now, so I can say that this sentence, if you notice this sentence, if you consider, then this is not this is a proposition, this is a proposition, but this is not an atomic proposition. So I can say this statement is not an atomic proposition because it has part which is a proposition. Okay, similarly you can take this example. So you can notice that in natural language like English, I can say a proposition is atomic. When can I say that a proposition is atomic? A proposition is atomic if we cannot find a part which is proposition. So read this statement. In this statement no part is a proposition. So this is an atomic proposition. I can say this statement is an atomic proposition because the truth value does not depend on the truth value of any other proposition. So there is no part which is a proposition. This complete statement is a proposition and it cannot be broken. Okay, but you can notice that this statement, if you notice this statement, we notice, then in this statement I can say that this part is a proposition. Socrates is man, this part is proposition. Plato is his pupil, this part is proposition. So this is also a proposition, and this part is also a proposition. So finally I can say that this is a proposition, but this is a compound proposition. Okay, so I can say that proposition is of two types. Okay, so what is a proposition? I can say proposition can be either atomic if it cannot be broken, or it can be compound if it can be broken. I can say atomic means no part is a proposition, compound means it has, okay, some part of it is a proposition. Okay, so this is the uh, two categories we can divide proposition, either it is atomic or it is compound. Okay, now the next concept we need to study is propositional variable. Okay, so what is the definition of propositional variable? So propositional variable, the definition is very simple. Propositional variable is a variable using which we can represent an atomic proposition. So I can say that atomic propositions are used to represent, okay, using propositional variable. For example, this is a proposition, this is an atomic proposition. So what I can do, this atomic proposition I can represent by a propositional variable p. This is also atomic proposition because no part is a proposition. So I can say this is an atomic proposition. This proposition I can represent by q. Now notice this. This is also a proposition, but you can notice that this part is basically p and this part is basically q. So I can say this overall, this is nothing but p and q. Okay, overall I can say that this is p and q. This is the symbol for and. Okay, this is the symbol for conjunction. So what is the propositional variable? Propositional variable is used to represent atomic propositions. Atomic propositions are represented using propositional variables. This is atomic proposition I can represent by propositional variable p. This is atomic proposition I can represent using propositional variable q. Okay, but this is not an atomic proposition. You can notice this part is basically p, this part is basically q. So I can say that this complete statement is basically nothing but p and q. Okay, so remember this p is a propositional variable, q is a propositional variable. So but this is not a propositional variable, p and q, this is not a propositional variable because these are propositional variable, this is not a propositional variable. So this p is a propositional variable, q is a propositional variable, and this is p and q. This is not a variable, this is not a propositional variable, this is basically composition of two variables p and q. So this is a composition of two variables. It's, for example, in mathematics, if you, okay, like in our mathematics, in normal mathematics, if you like, okay, that we study in our school life, or I can say uh, okay, so in normal mathematics or number theory or algebra, okay, in normal mathematics what happens, for example, if you have a variable, okay, let's assume you have variable x, you have variable y. We say that x, okay, x plus 2y is equal to xy something. Okay, so here you can notice this is a variable, I can say this is a variable. Similarly, this is a variable. Okay, this is a variable. Now this is not a variable, we cannot say that this is a variable. Like xy is not a variable, xy is not a variable, this is a combination of variable, I can say. Okay, so I can say x is a variable, y is a variable, but xy is not a variable. Okay, this xy is basically the combination of two variables, or I can say this is multiplication of two variables. Okay, so similarly in this propositional logic, I can say that propositional variable, atomic propositions are represented by propositional variables. Atomic propositions, they are represented by propositional variables. And this compound proposition, this is nothing but this part is p, this part is q. So finally I can say that this compound proposition is p and q. Okay, so this p and q is not a propositional variable, this p is a propositional variable, q is a propositional variable. Okay, let's move on. So I can say that so basically we represent atomic propositions by variables. Okay, so every atomic proposition we represent by variable. These variables are called propositional variable because they are representing atomic propositions. Okay, so I can say atomic propositions are represented by propositional variables, compound propositions are not. Okay, so here you can see that atomic proposition, like this is an atomic proposition, so I can represent this by a propositional variable. Okay, this atomic proposition I can represent by a propositional variable, so I can say this is a propositional variable. Okay, now remember this is also a proposition, you can notice this is also a proposition, but this is compound proposition. So we don't represent compound proposition by a proposition variable, don't do this. Okay, don't do this. Why? Because propositional variables are used to represent atomic propositions. Atomic propositions are represented by propositional variables. So this atomic proposition we represent by propositional variable, but this is a compound proposition. So here you can notice this part is a atomic proposition. 2 is an odd prime. This part is atomic proposition, so we can represent by a. This part is a proposition, this part is atomic proposition, we can represent by b. So this complete statement we can represent by a and b. Okay, so this is the idea. So I can say that atomic proposition we represent by proposition variable. Now similarly, this part is atomic proposition, this part is atomic proposition. So finally this proposition I can say that this is a and b. Okay, this is called propositional formula. This is actually called propositional expression. We don't call it propositional variable. This is called propositional expression. Okay, so we call it propositional expression. Similarly here, this is a compound proposition, so don't represent this by a propositional variable. So we cannot represent by a propositional variable. This q is not a propositional variable because we don't represent compound proposition by a propositional variable. Okay, now this part is an atomic proposition, we can represent by p, and this part is a atomic proposition, we can represent by q. So finally this complete proposition I can represent by p or q. Okay, so this is called propositional expression. This is not a propositional variable, this is called propositional expression. For example, as you notice here, this xy is basically called expression, I can say. This is expression, we don't call it variable. This is not a variable, but this is expression. Variable is x comma y, these are variable. Okay, so this is the final conclusion. Atomic propositions are represented by propositional variables. So propositional variables represent atomic propositions. Okay, so this is atomic proposition, I can represent by variable p. This is atomic proposition, I can represent by propositional variable q. Now you can notice that this part is basically p because grass is green means p. Okay, and this part is basically q because snow is white, that is q. Okay, so this proposition variable q. So finally I can say that this complete statement, I can say that this is nothing but p and q. Okay, this p and q, this is expression. Remember, this is expression, this is not a variable. Okay, don't say that this is a variable, this is basically expression. Okay, this is not a variable, this is not a variable, I can say. This is not a variable, this is a expression, this is expression. Similarly, what about grass is not green? What about this? So very simple, grass is not green. Okay, you can also write it like this: it is not the case that grass is green. Okay, so again you can notice that this is a compound proposition. Remember, this grass is not a green. Why? This is a compound proposition because this part is a proposition. So this is compound proposition, this is compound proposition because this part is proposition. So this is not an atomic proposition because this part is proposition. Okay, so this part is basically p. Okay, grass is green, if I represent by p, then you can notice this part is basically p, and this, it is not the case, so this is negation. So I can say that this is negation p. Okay, so this is, again, this is not a variable. Remember, this is not variable. Again, this is not variable, this is basically expression, I can say. This is basically expression, this is not a variable, this is expression. Okay, so this is the point. So propositional variable may also be called atomic proposition because we represent, okay, propositional variables, they basically represent atomic propositions. So I can say propositional variable is basically atomic proposition, and compound propositions we can create by using these atomic propositions and these logical connectives. Okay, so compound propositions we can very easily create using the atomic propositions and using the logical connectives. Okay, so this type of statement, for example, this statement, this is a proposition, but this is not a atomic proposition. Atomic proposition is like p, basically. For example, this is atomic proposition, this is atomic proposition, and this is compound proposition. So atomic proposition is like atom, right? This is like atom. Okay, so basically this atomic proposition is the fundamental block of, okay, this is the fundamental block. Using these atomic propositions and using these connectives, we can create complex propositions. We can create compound propositions, or I can say complex proposition. So you can notice that, Okay, so this is the analogy. So atomic propositions are like atoms, so I can say these like these. Okay, for example p, for example q. Okay, so I can say for example r. So atoms, I can say atomic propositions, they are like atoms. Okay, and using these atomic propositions, from these atomic propositions, what we can do, using logical connectives, for example. Okay, so using logical connectives we can create compound propositions. So this is the analogy. Okay, so atomic proposition is like an atom. Okay, this is the fundamental block, this is the fundamental thing. Okay, and using connectives, what we can do, we can create complex propositions, we can create compound propositions, we can create. Okay, now the next concept is propositional formula, or I can say propositional expression or propositional form, or you can call it well formed formula, or you can, another name is well formed formula. Now what is this concept? So propositional formula. So what is this concept? Propositional formula, or you can say propositional expression. This we have already seen. For example, you can notice that if you have propositional variable, let's assume here that you have propositional variable PQ. Okay, so this PQR, let's assume these are propositional variable. What it means? Remember, propositional variables, they represent atomic proposition. So basically, this is representing atomic proposition, this is representing atomic proposition, and this also represents atomic proposition. Okay, so these are basically atomic propositions. And I told you atomic propositions are either true or false. Atomic propositions, they by itself is true or false. They do not depend on anyone else. This does not depend on anyone else. The truth value of P does not depend on anyone else. The truth value of Q does not depend on anyone else. Okay. So let's assume that these are proposition variables P, Q, R. Okay, if these are propositional variables, then what we can do, we can create expression. For example, I can create this expression. So this is called expression. So remember, this is called propositional expression. Let's call it PE. So in short I will call, so let me okay, propositional expression. In short I will write PE, means propositional expression. So this is a propositional expression. I can say that Q implies R. This is also propositional expression, or I can say propositional formula. Okay. For example, P and P dash. This is also propositional expression. For example, P dash. This is also propositional expression. So these are propositional expressions. So if you have propositional variable, propositional variables will represent atomic propositions. Atomic propositions are, they do not depend on anyone else. So the truth value of R does not depend on anyone else. The truth value of P does not depend on truth value of anyone else. Okay, but you can notice the truth value of this will depend on the truth value of Q, also truth value of R. So you can notice the truth value of propositional expression. This is the propositional expression. The truth value of this expression will depend on the truth value of these atomic propositions. Okay, so the truth value of this expression will depend on the truth value of these propositional variables. Similarly, the truth value of this expression will depend on the truth value of these propositional variables. Okay, so this is the idea. So what is the definition of expression, I can say? So finally, if I want to define what is a propositional formula, so finally, what is a propositional formula? Let's define this propositional formula, or I can call it propositional expression. So what is a propositional formula? So I can say that every atomic proposition is a propositional formula. So every propositional variable is a propositional formula. So every propositional variable means atomic proposition, because atomic propositions are represented using propositional variable, and propositional variables, they represent atomic propositions. Okay, so it's like this. So I can say that every propositional variable is a propositional formula. For example, I can say that this P is like, if this is a propositional variable, then this is also a propositional formula. This is also propositional formula. This is also propositional formula. So these are propositional formula. What next? Next is true comma false is also propositional formula. So true comma false, T comma F, they are also propositional formula. What else? Now, if anything is propositional formula, then you can create new formula using connectives. So using logical connectives, we can create new propositional formula. So I can say that if anything, for example, if G, Okay, so I can say if G is a propositional formula, or I can say if G comma H, let's assume. So if G comma H are propositional formula, so if G comma H are propositional formula, then we can create new formula using logical connectives. Okay, so if they are propositional formula, then negation of G is also propositional formula. G and H is also propositional formula. G or H is propositional formula. G implies H is propositional formula. Bracket G is also propositional formula. By implication is propositional formula. Okay, this NAND is propositional formula, and similarly I can say this NOR is also propositional formula. So what I can say that if you have, so if G comma H are propositional formula, then negation, you can do the negation, you can do conjunction, you can do disjunction, implication, by implication, NAND, NOR, or you can also do exclusive OR. Okay, so basically all these are propositional formula. So the definition is very simple. What is a propositional formula? Proposition formula means every proposition, or I can say that every atomic proposition, every propositional variable is a propositional formula. So P is a propositional formula. This is also propositional formula. True comma false, they are also propositional formula. And if two things are propositional formula, then you can do their negation, disjunction, conjunction, implication, by implication, exclusive or NAND or all these things. Okay, so my question is, which is a proposition formula? So so you can write that if P is a proposition variable, then this is a propositional formula. Q is a propositional formula. R is propositional formula. I can say that because this is a propositional formula, this is a propositional formula. So I told you that you can do implication. So this is also propositional formula. You can do by implication. So this is also propositional formula. Now this is propositional formula. This is propositional formula. So I can say that you can do their disjunction. So this is also propositional formula. Okay, now you can notice this is a propositional formula and this is a propositional formula, so you can do their exclusive OR. So let me do their exclusive OR. So you can notice this is a propositional formula, so this is a propositional formula and this is a propositional formula, so their exclusive OR is also propositional formula. This is also propositional formula. Okay, so the definition is very simple. We can say that atomic proposition, every propositional variable is a propositional formula. You can note here, okay, you can note here basically variable. Okay, I can say propositional variable means atomic proposition. Remember this point always. Atomic proposition means proposition variable, or I can say propositional variable means atomic proposition. Okay, so every atomic proposition, or I can say atomic propositional variable is a formula. True comma false, they are also formula. If two things are formula, then you can do negation, conjunction, disjunction, implication, by implication, and so on. Okay, all these things you can do. Okay, so this is the definition of propositional formula. Now, what is not a propositional formula? For example, this type of things are not propositional formula. So what is not a propositional formula, or I can say what is not a well-formed formula? For example, this type of things, like this type of thing, this does not make any sense. Okay, for example, this does not make any sense. So these type of things, they are not a propositional formula. For example, this does not make any sense. Okay, so this is also not a propositional formula. For example, this does not make any sense. This is not a propositional formula. This does not make any sense. This is not a propositional formula. So propositional formula definition is very simple. Basically, whatever is well-formed formula. For example, if I write P implies Q implies R, this is also propositional formula. For example, this is also propositional formula. This is also propositional formula. True implies P. This is propositional formula. False, okay, this is propositional formula. Okay, so these are propositional formula. Now, the last part. Okay, so before that, you can very easily see that this is just a terminology. I told you that propositional variable is like an atom, correct? Okay, so I can say what is atom actually. This is just a terminology. This is not a standard terminology. You don't have to worry about it. Okay, what is atom? Atom basically any propositional variable PQR. Okay, any propositional variable that is also atom. True comma false. These are also atom. Okay, so actually I told you that atom means this is the very basic building block. Okay, so these are the atoms. Propositional variable PQR, these are the propositional variable, means these are atomic proposition. So every atomic proposition is a atom, or I can say true comma false, these are also atom. So these are very fundamental concepts. Now what we can do, we can create using logical connectives. Using logical connectives we can create more complicated propositions. Using logical connectives we can create more complicated expressions, like okay, like we can create more complicated expressions. Okay, so these are called formula. So okay, so atom means atomic proposition comma true comma false, these are called atom. Okay, and these are called formulas. This is called formula, this is called formula. Okay, so this is the definition of a formula. For example, if f is a formula, then negation is, we can do negation, conjunction, disjunction, all these things we can do. Okay, so this is the idea. Now for example, also what is the definition of literal? What is a literal? Basically p is a propositional variable. This is a propositional variable, so this p comma p bar, these are called literals. Remember, this is propositional variable, we know that this is propositional variable. Okay, this is not a propositional variable, but this is literal. So I can say p is a propositional variable, then p comma p bar, these are literals. So for example, if I say p or if I have this p or p bar q, okay, if I have this, then how many literals we have here? So we have three literals. This is a literal, this is a literal, this is a literal. Okay, so literal means p comma p bar. This type of thing means propositional variable and its a negation. They are called literal. For example, in this expression, how many literals we have in this expression? In this expression, you can notice that how many literals we have. So this is a literal, so you cannot, this is a literal, this is a literal, this is a literal. Okay, so this is the definition of literal. Next, for example, you can notice here, this is a formula. If you notice, this is a formula, this is not a proposition. Sorry, this is a proposition, but this is not a propositional variable. This is a formula. This is not a variable, this is not a variable, this is a formula. Okay, so this is a proposition, this is a compound proposition, and so I can say this is a formula. In this, you can notice these are the atoms. This p is atom, so every proposition variable is atom. So this atomic proposition, these are atoms, so these are atoms. And literal means this is also literal, q is also literal, p is also literal. Okay, so these are literal. For example, true is also literal. So these are the literals here. Okay, and these are sub formula, these are the sub formulas. For example, this is a sub formula, this is a sub formula, you can note this is a sub formula. So this is the terminology. So I hope the definition of formula is clear. Formula versus a propositional variable. So propositional variable versus propositional formula. So you can notice that if this is propositional variable means atomic propositions. These are the basic building blocks. So these are the atomic propositions. Their truth value does not depend on truth value of any other proposition. The truth value of this r that does not depend on anyone else. So these are propositional variable means basically atomic propositions. These are basically atomic propositions. So this p comma q comma r, they do not depend on anyone else. Their truth value does not depend on anyone else. They are either true or false. So atomic proposition by itself is either true or false. It does not depend on anyone else, it is independent. Okay, so it is either true or false. By itself it is either true or false. But notice propositional formula. For example, p and p bar, this is a propositional formula. P and q, this is a propositional formula. So the truth value of propositional formula will depend on the truth value of these propositional variables. The truth value of this propositional formula will depend on the truth value of these propositional variables. Okay, so this is the difference between propositional variable and propositional formula. For example, this is a propositional formula, I can say. So okay, you can notice this is a propositional formula. In the truth value of this proposition formula will depend on the truth value of p comma q. Okay, so this p comma q, these are the, this p comma q, these are the atomic propositions, or I can say these are the propositional variables. So propositional variable represents atomic proposition, or I can say atomic proposition is represented by propositional variable pqr. And proposition formula, this type of things are formula. For example, I can say that p by implication p bar, this is also a propositional formula. So this type of things, this type of compound propositions, you can notice. Okay, so this type of things are called propositional formula. Okay, remember this is also a propositional formula. I can say this p is also a propositional formula, this q is also propositional formula. I told you the definition of propositional formula. Okay, so the propositional formula, every propositional variable is also a propositional formula. True comma false is a propositional formula. And if you have any propositional formula, then you can do conjunction, negation, implication, all these things. Okay, So this is the whole idea. Now finally, what is the definition of propositional logic? This is the question that I wanted to ask you. This is the question, okay, we basically we asked in the beginning of the video. So now can you define what is a propositional logic? Okay, in interview if they ask you what is the definition of propositional logic, then how will you define it? Okay, so let me define it. Propositional logic, this is basically a world of true comma false. Every variable is either true or everything is either true or false in this world, in this propositional world. This is a world of true comma false. Everything is either true or it is false. So I can say that every variable is also either true or false. Every variable is called propositional variable. Okay, and propositional variable represents some atomic proposition. So it is like this. Remember, again I am telling you, for example, if you have like x square plus y square is equal to, let's assume, xy, okay, xy plus some, okay, something. So here you can notice this x is a variable. You can note this x is a variable. Okay, this x is a variable. This is not a variable, this is expression. I can say this is expression. So this is not a variable. So this y is a variable. I can say this y is a variable. So what I'm saying here I'm saying that every variable is either true or false in this propositional logic world. Everything is either true or false. Every variable is true or false. Every variable is called a propositional variable, which represents atomic proposition. Atomic proposition is either true or false by itself. Okay, so you can notice every variable, you can also call it boolean variable. Why? Because it only takes one of the two values, either true or false. So whatever variable you have, that is either true or false. Every propositional variable is either true or false. Now what is propositional logic actually? So this propositional logic is basically, okay, you can give the definition like this, that propositional logic is collection of all the propositional formula. That's it. So if someone asks you what is the definition of propositional logic, okay, so what is the definition of propositional logic? Propositional logic is a set of all propositional formulas. So what is a propositional logic? So I can say that propositional logic is basically the set of all propositional formulas. Okay, so for example, every proposition formula, every propositional variable is a formula. Every propositional variable is a formula. True comma false is a formula, and also any combination of them using logical connectives, like, okay, like negation is a propositional formula. This is a propositional formula. Conjunction is propositional formula. Implication is propositional formula. So the point is very simple, that propositional logic means this is set of all propositional formulas. Okay, so this is the definition of propositional logic. This is the collection, this is the set of all propositional formulas. Okay, every propositional variable means every atomic proposition is a formula. It's like every atom is a formula. Okay, true false is a formula, and any combination using logical connectives, any combination is also propositional formula. So I can say this is the definition of propositional logic. So remember, propositional logic is a world of true or false. Every variable is either true or false. Every variable is called propositional variable. Propositional variable represents atomic proposition. Using atomic propositions, from atomic propositions using logical connectives, we can create new propositions which are compound propositions. Okay, and what is propositional formula? Every propositional variable is also propositional formula. True false is propositional formula, and any combination of propositional formulas using logical connectives, that is also propositional formula. So this is the definition of propositional logic. Okay, if anyone has any doubt, you can ask in the comments. So these concepts are actually useful. Okay, so in the next lecture I will tell you why these concepts, all the concepts that we have seen, why they are important. So you should understand the difference between propositional formula and propositional variable. Okay, remember, every propositional variable is a propositional formula, but propositional formula does not mean that it is a propositional variable. Like this, like you can notice, okay, this is a propositional formula. This is not a propositional variable. P is a propositional variable. Q is a propositional variable. Okay, so every propositional variable is a propositional formula, but you can create many propositional formula you can create. So we have seen all the definitions. Okay,